Hi, Algebra 2 Honors. So this is not a normal video that I would give you because I am sick right now. So this is sort of a what do I do if I can't be in class today video. So I trust that you guys will be able to take these notes that I'm about to show you. Unfortunately, I did not have a copy of this paper made for you. So please, at this point, if you do not have notes or a piece of paper to take notes upon, please go get one. And calculators might be good, but a lot of these numbers are going to be relatively nice today. So let's try some stuff. This is section 4.5, which is called completing the square. We're not actually going to get to the method of completing the square today, but today we're going to get to this thing called the square root property, which we need for completing the square to work. So here we go. We, so far in Chapter 4, have talked about how we solve quadratic equations a couple different ways. We've already talked about graphing, which we did. We found the x-intercepts to our parabolas. Those are our solutions. We have talked about factoring, which works when we have nice factorable solutions or equations. And that's it so far. We've already started talking about how we deal with imaginary numbers, and imaginary numbers and the idea of taking the square root of both sides is kind of what the square root property is telling us we're allowed to do. So, and I realized I actually said something incorrect in class a while ago. I said there are 4 methods for us to solve these. Really, there are five methods. Graphing, factoring. Today we're going to talk about the square root property. That is number 3. Completing the square kind of goes along with that one. So that might be like 3a, something like that. So anyway, here we go. The square root property works if we have, and it says this note right here on this page, you can copy that down, if we have a perfect square trinomial equaling a constant. Now that constant can be 0. So far with graphing and factoring, it had to equal 0. But now with the square root property, it doesn't have to be 0. What has to happen in this case, it has to be a perfect square trinomial, which we have worked with before, but we didn't call them that. But what it is just a fancy form, a unique special form of a trinomial, which we factored, but now they factor super, super nicely, and we've seen that, we just didn't note them specially. So here we go. A perfect square trinomial has the form, like all trinomials, ax squared plus bx plus c. But it can be factored into this form, like we always have. 2 spaces, I'm going to reverse FOIL. It's going to have some number out here. Let's use, since A, B, and C are already used, let's use M and P. MX, MX, so those 2 pieces are going to be the same, plus, or they could both be minus, P and P. So they have to be identical. Like every single aspect of this binomial has to match every single aspect of this binomial. So I could also factor it if they were both needing to be negative P. That's allowed as well. The key is that they match. So they have to both be positive, both be negative. MX, MX, P, and P. Here are some examples fully solved out for you. This one, the answers are very, very nice integers. This one, we have some irrational numbers. We can deal with both of those. So take a look at what I mean here. We have x squared minus 8x plus 16 equals 25. Now last week, we would subtract that 25 and see if we can do anything at that point when it equaled 0. But now we don't have to, because this guy right here, that trinomial, is a perfect square trinomial. Meaning, I can factor it into x and an x 16 can come from 4 and 4. And I need a negative 8 in the middle, so I'm going to make this negative and negative. And remember, whenever you factor, even when it's a perfect square trinomial, you can check your factoring by foiling. So real quick, I'm just going to FOIL this to check. I have x squared minus 4x plus 16. And right here in the middle is how you know you have a perfect square. Because if this wasn't a negative 8 in the middle, if it was just the x squared and 16, there's a lot of options. I could have used 8 and 2 to get me 16. I could have used 1 and 16 to get me 16. But because I'm using 4 and 4, and in the middle I get negative 8x, I know it's a perfect square trinomial. So a good hint is to look at first the first term, the last term. Are they perfect squares? So are the first and last terms perfect squares? That is step one. But then look at the middle. Look at the middle term. It should be in the form, in this case, we'll go back to our m, x, and the p situation here. It's always going to be the mx piece times the p piece doubled. Because notice what happens here. I get x times negative 4, there's one of them, and then x times negative 4 in the middle as well. So because those two pieces are going to match, it's always going to be double what I get when I multiply them. So over here, I'm just going to write my middle term is always going to be in the form 2 times m times p, and then there will be an x on the end, or whatever variable it is. In this case, if it was positive, it's going to be positive. If it was subtracting, it's going to be subtracting. So in my case here, negative 4x, when I saw right here, I could have said, oh, well, if I have x negative 4 times x is negative 8x, is negative 4x, doubled is negative 8x. Look at that. Hooray, life is good. So look at the middle term. It should be twice the product of your two, I'm going to say factor components. So right there. Twice your factored components, which we have, and life is good here. Hooray. So that is a perfect square trinomial. And the reason why this helps us, why it's nice that this happens, is because I can take this factored form and rewrite it as this factored form. Notice what happened there. I just took my piece, since there's two of them, and wrote it once but squared it. That's the key. Now that it is squared, I am allowed to take the square root of both sides. Here is where the square root property comes into play. I take the square root of both sides. I get normal x minus 4. And we know when we take the square root, I'm going to get a positive and a negative option. So the square root of 25 normally is 5. The negative square root of 25 is negative 5. So then, we're not done solving yet. Last week when we did the imaginary equations, where the answer was imaginary, we would stop at that point because it was x equals this number. But at this point, and they didn't show this here, I wish they would have in this page, so at this point, they have x minus 4 equals 5. But that's not a solution, not yet. So I just need to add 4 to the other side, which is what they're doing right here. Marker dying. There we go. So what they're doing right there, they just added 4 to the other side. So my answer is actually 9. And they did that over here as well. I get negative 5, but I add the 4 to the other side, so my answer is actually negative 1. So my solution set, as they call it, is 9 and negative 1.